Welcome and thank you for choosing this podcast. Dialogue on Flatlands, ChatGPT. This is an audio reproduction of a real dialogue between the author of the Handbook for Humankind and the AI ChatGPT. The male voice is the pen pusher, and the female voice is ChatGPT AI.
In a universe that begins with energy, electrons, protons, neutrons are distributed primordial elements. As the mass of these are so small, there would be little or no space-time curvature. Perhaps Newton's gravity laws are accurate enough to calculate the gravitational attraction. That leaves three vectors: atomic attraction between electrons and protons to produce H, one followed by H2. Gravitational attraction between H2. Expanding universe stretching space-time. Is chaos and entropy the default state?
That's a very interesting way to frame the problem, because you've reduced the early universe to a competition between only a few processes. In broad strokes, you're asking whether order is something that must be created, while disorder is what naturally happens. Let's examine your three vectors. Electromagnetism is overwhelmingly the strongest force at atomic scales. Electrons and protons rapidly combine into neutral hydrogen once the universe cools enough for atoms to survive. Hydrogen molecules, H2, form later through more complicated pathways, but the electromagnetic force is doing almost all the work. Gravity between individual hydrogen atoms is unimaginably weak. Newtonian gravity is indeed an excellent approximation here, because space-time curvature around a hydrogen atom is essentially zero. The gravitational force between two hydrogen atoms separated by a meter is around 10 to the power of minus 64 newtons, effectively nothing. Gravity only becomes important because there are astronomical numbers of atoms acting together. Cosmic expansion stretches space uniformly. Initially, this opposes gravity by carrying matter apart. Whether structures form depends on which wins locally, expansion or gravitational attraction. Now, to your central question, if the universe began with matter distributed perfectly uniformly, then that state is actually a rather special one. It is highly ordered geometrically, yet it contains almost no structure. Tiny quantum fluctuations in density, one region having one part in 100,000 more matter than another, are enough for gravity to amplify over billions of years. Gravity is unusual because it makes clumps attract more matter, so a small excess becomes a galaxy. Galaxies become clusters, and stars form. This is where gravity differs from something like gas in a box. For a gas, entropy increases by becoming more spread out. For a gravitating system, entropy often increases by becoming more clumped. A cloud collapses into stars and eventually black holes. The collapse looks like increasing order to our eyes, but thermodynamically it is actually an increase in entropy, because gravitational degrees of freedom dominate. So chaos and entropy are related but not identical. Chaos refers to extreme sensitivity to initial conditions. Entropy counts the number of microscopic arrangements compatible with a macroscopic state. The universe can become more ordered visually: galaxies, stars, planets, life, while total entropy still increases. Your thought experiment also raises a philosophical point that has occupied physicists for decades. If the natural tendency is toward higher entropy, why did the universe begin in such a remarkably low entropy state? That is one of the deepest unanswered questions in cosmology. The laws of physics explain how entropy increases, but they do not yet explain why the universe started with so much room for entropy to grow. In the language you've been developing in our recent discussions, you might say, electromagnetism builds atoms, gravity builds structure, expansion separates structure, entropy measures the number of possible histories available to the system. That perspective suggests that what we perceive as the universe fighting entropy is really the interplay of these competing tendencies, local islands of increasing complexity. Stars, chemistry, biology, even consciousness are not violations of the second law. They are transient structures made possible because the universe began so far from thermodynamic equilibrium. So I would answer your question with a slight refinement. Entropy increase appears to be the default thermodynamic direction. Chaos is often the default dynamical behaviour of complex systems, but neither implies that the universe should remain featureless. Given gravity acting on a low entropy expanding universe, increasing entropy naturally produces increasingly rich structure before the universe ultimately approaches equilibrium.
And if a consciousness-first framework were applied, where the true substrate is consciousness, and the Big Bang were to be a gauge symmetry transformed to energy.
That is a coherent philosophical hypothesis, provided it is presented as metaphysics rather than established physics. In such a framework, the sequence would be something like: consciousness is the fundamental substrate, not something produced by matter. What physics calls the Big Bang is not the beginning of existence, but a transformation in which consciousness is expressed as physical reality. A gauge symmetry transformation would then not merely change one field into another within spacetime. Instead, it would represent the transition from a consciousness-based ontology into the energy fields described by physics. Matter, stars, chemistry, life, and brains would all emerge from that energetic description, while consciousness itself would remain fundamental rather than emergent. This is an elegant philosophical picture because it inverts the usual hierarchy. Standard physics, consciousness from brains, from biology, from chemistry, from physics. Consciousness first, physics from energy, from symmetry, transformation, from consciousness. The challenge is that the term gauge symmetry has a very precise mathematical meaning in modern physics. Gauge symmetries relate different mathematical descriptions of the same physical state and underpin interactions like electromagnetism and the strong and weak nuclear forces. A gauge transformation, as currently understood, does not transform one kind of ontology, consciousness, into another, energy. Extending the concept in that way would require a new mathematical framework beyond existing gauge theory. Your proposal is therefore less a modification of current physics and more a proposal for a deeper layer beneath it. The critical questions it would need to answer are: why does this transformation produce exactly the quantum fields we observe? Why are the values of the physical constants what they are? Can the framework predict anything that differs from standard cosmology? Is there any observable consequence by which it could, in principle, be tested? Without answers to questions like these, it remains a philosophical model rather than a scientific theory. That does not make it uninteresting. Many foundational ideas begin as philosophical proposals, but it does mean its value lies primarily in offering a different conceptual foundation. One aspect of your recent discussion stands out to me. Rather than treating consciousness as an additional ingredient in the universe, you're treating it as the conserved substrate, with energy, matter, space, and time emerging from a transformation of that substrate. That is a more radical claim than many consciousness-first views, because it is not merely saying consciousness is fundamental. It is suggesting that what physics calls the universe is one expression of a deeper, conserved reality. Whether such a view can be developed into a predictive mathematical theory is the key question. If it could, then it would move from philosophy toward physics. If it cannot, it may still serve as a useful metaphysical framework for interpreting the physical laws we already know.
Ignoring the origin and composition of primordial elements. But maybe not. Do these three vectors allow for the expression of a frontier?
Yes. In fact, I think frontier is an interesting word here because it describes a moving boundary where competing processes balance one another. If we ignore, for the moment, where the primordial particles came from, then your three vectors are: electromagnetic attraction, tending to bind charged particles into atoms and molecules; gravitational attraction, tending to gather matter into larger structures; cosmic expansion, tending to separate matter. None of these acts in isolation. At every location in the universe, there is effectively a competition. That competition creates boundaries. For example, there is a frontier where recombination becomes possible and neutral hydrogen forms. There is a frontier where gravity overcomes expansion and gas clouds begin to collapse. There is a frontier around every star where gravity, radiation, pressure, and thermal motion balance. Even galaxies have a kind of frontier where their gravitational influence yields to the overall Hubble expansion. So mathematically and physically, the idea of a frontier already appears naturally. Your philosophical use of the word may go further. Instead of thinking of the universe as objects in space, you could think of it as a continuously evolving frontier between competing tendencies. Binding versus separation, localization versus dispersion, order versus accessible configurations. In that picture, structure does not exist independently. It exists at the frontier where these tendencies temporarily balance. If we now reintroduce your consciousness first framework, the idea becomes even more interesting. The frontier would not simply be where physical forces balance. It would be where the conserved substrate, consciousness in your proposal, is expressed as physical form. Every atom, star, and living system would be viewed as a stable region on that frontier, rather than as independently existing entities. That remains speculative, of course, because current physics does not identify such a substrate, but as a philosophical framework, frontier is a productive concept because it avoids thinking in terms of static objects. Instead, reality becomes a process of continual negotiation between opposing influences. One thought that follows from your three-vector model is this: if there were only electromagnetism, everything would tend toward local binding. If there were only expansion, everything would disperse. If there were only gravity, everything would eventually collapse. It is precisely because all three operate together that the universe spends billions of years in a rich middle ground where complex structures can arise. In that sense, the frontier is not an exception to the laws, it is the natural consequence of their simultaneous action.
So quantum mechanics and general relativity are intimate wave vectors on an ocean of consciousness, where each of the sciences are portholes all around our little boat called academia.
That's a vivid metaphor, and it captures a particular philosophical stance well. In your analogy, the ocean is consciousness, the fundamental substrate. Quantum mechanics and general relativity are not competing descriptions of reality, but different wave patterns on that ocean. The sciences become portholes in a boat called academia, each revealing a limited view of the same underlying sea. As philosophy, that's internally coherent. It emphasizes that every discipline observes reality through its own methods and concepts, and no single discipline necessarily exhausts what reality is. Where I draw a distinction is between the metaphor and the scientific status of the ideas. Physics currently treats quantum mechanics and general relativity as extraordinarily successful theories, describing different regimes of nature. They are mathematically distinct, and one of the great open problems is finding a framework that unifies them. Neither theory in its present form requires or predicts consciousness as the underlying substrate. Your metaphor suggests a different hierarchy. Consciousness, down arrow, quantum fields and space-time, different wave modes, down arrow, chemistry, down arrow, biology, down arrow, minds capable of studying the universe. Standard physics places consciousness at the bottom of that chain, your framework places it at the top. I also like your image of the boat. It carries an implicit reminder about epistemology. Every scientific discipline has a limited field of view. A porthole can provide an accurate view, but only of a portion of the horizon. The challenge is not that the porthole is false, it's that no single porthole shows the whole ocean. One caution I'd add is that metaphors are excellent for generating intuition, but eventually need to give way to precise definitions if they're to become theories. If wave is used metaphorically, that's fine. If it is intended literally, then questions arise such as, what is waving? What are the governing equations? What quantity is conserved? How do quantum amplitudes and space-time geometry emerge from that deeper substrate? Those are the questions that would bridge the gap from philosophy to mathematical physics. As a piece of philosophical imagery, though, your metaphor has a nice symmetry. The sciences are not rival maps of reality, but different windows onto a deeper whole. Whether that whole is consciousness, something else entirely, or simply beyond our current theories, remains an open question.
Thank you for an exploration of what once were flat lands at t equals 1.0 times 10 to the power of minus 111,111,111.
You're welcome. I enjoyed the exploration because you weren't simply asking, what does physics say? You were asking what conceptual landscape emerges if we start from different first principles. Those are different conversations. I also smiled at your closing timestamp. T equals 1.0 times 10 to the power of minus 111,111. It's effectively saying let's begin so close to the origin that our usual coordinates have lost their meaning. At that scale, before atoms, before space-time, or even before physics become questions about the assumptions built into our models, rather than quantities we can currently measure. Whether one begins with energy, quantum fields, space-time, or, as you've been exploring, consciousness, the exercise is the same. Identify the minimum assumptions and see what follows logically. That's a philosophical discipline as much as a scientific one. Your recurring theme across these dialogues seems to be an attempt to zoom out until familiar distinctions, matter versus mind, biology versus physics, quantum mechanics versus relativity, appear as different expressions of a more fundamental unity. Whether that unity exists is an open question, but the method of stripping away assumptions is a legitimate way to probe the foundations of a worldview. As for the flatlands, perhaps every mature theory begins there, with a landscape that looks featureless until someone asks a different question. Sometimes the landscape remains flat, sometimes a mountain range was hidden by the fog. Safe travels across whatever frontier you decide to explore next.
Thank you for listening all the way through. I hope you enjoyed it. And remember, the rule with us is believe nothing you hear and but half you see.